So in this video I want to talk to you about parametric equations. Now parametric equations are equations that have a parameter in them. Now parameter is usually t or theta in this case, and it represents something that's changing. So here we're looking at two equations. We've got x equals 2 plus 3 cos theta, and we've got y equals 1 plus 3 sine theta. Now these two equations here are the parametric equations together. And the interesting thing is that you actually have two equations that describe a circle. Now we know that you can do that using one equation. So what we're going to do is we're going to try and find that one equation, what we call the Cartesian equation, by putting these two things together. And what we need to do is find a link between these two things that don't look like they can link at all. They've got sine and cos. But the one super useful thing you can always use in spec maths is this expression, sine squared theta plus cos squared theta equals 1. It's what's called the Pythagorean identity. And this helps us to link together any expressions that have sine and cos in them. So we're going to use this idea here. So what we're going to do is I'm going to take the first expression that I've got, this x, I'll call this expression 1, and I'm going to solve it for cos theta. Okay, so what I'm going to do is take the 2 to the left side, and I'm then going to divide both sides by 3. So I have this. That's my first part here. The second thing I'm going to do is look at the second equation. I'm going to solve this now for sine theta. So 1 to the left and divide both sides by 3. And that gives me this equation here. Now you can see here we've got sine and cos. What that means we can do is we can actually take both of these things and put them into this Pythagorean identity. Oops, I should draw that arrow to the cos. So we can put the cos in and we can put the sine into here. So what we're going to do is we're basically going to just do a substitution. We know that this is true for all values of sine theta and cos theta. So these just happen to be my sine theta and my cos theta. So I'll put on my next line using the Pythag identity, we have sine theta, which is y take 1 on 3, sine theta squared plus cos theta, which is x minus 2 on 3, cos theta squared equals 1. And if we expand this a little bit, I'm just going to expand the bottom. So I'm going to leave the top inside a bracket, and 3 squared on the bottom is 9, and again leave the top in a bracket, 3 squared on the bottom is 9, and I can even take that 9 over to the right hand side, and we end up with this. Now you'll probably recognize the format here. This is a circle, and it is a circle with radius of 3, because remember it's radius squared on the right side, and this circle also has a centre at, now the way I've written it here can be a little bit confusing because I've actually got the y first. So if you wanted to, you could absolutely pick this up and move it so it's in a nice format that you're happy with, like so. So now we can see the centre nice and clearly is where we've got x at x minus 2 at the start there, so the centre is going to be at 2. Remember, it's always the opposite, and 1. So what we've done there is we've managed to take a parametric or a set of parametric equations using the Pythagorean identity and solving each of those equations for sine and cos. We could then find ourselves a Cartesian equation, and this particular circle here we're asked to find the domain and range. Now we know we could sketch this. So we could just grab some lines here. You don't have to sketch it. You can probably figure this out without a sketch, but just so you can understand what's going on. Just some tick marks, roughly evenly spaced. Oops. Okay, so our centre is at 2, 1. We have to move 3 in each direction. 1, 2, 3, 1, 2, 3, 1. Oops, 1, 2, 3, and 1, 2, 3 for our circle. And you can see here that our domain, so remember that's going from left to right, goes from -1 inclusive over to 2, 3, 4, 5, because you're adding 3 onto that 2. And then range, same idea. This time this is going up and down. So adding 3 onto the 1 we get to 4, taking away 3 from that 1 we get to -2. So -2 to 4 inclusive. So that's our domain and range for our circle.